Hassan's Maths channel. I'm now answering question number 4 from the June 2024 Pure Mathematics P2 paper from the Edexcel International A-Level exam. This question here, we have a question about the remainder theorem and the factor theorem, algebraic long division, all these type of things. Now here it says f of x is equal to x minus 2 in one bracket times 2x squared plus 5x plus k in another bracket, and then outside all of that is plus 21. It says where k is a constant, we've got to state the remainder when f of x is divided by x minus 2. It's worth 1 mark and it says state, which means if you just write down the answer, you will get the marks without showing any steps, because it says, it uses the word here, state. Okay, and I can see the answer is going to be 21. The answer is just going to be 21. If I just write down 21, I'll get the marks. And now I'm going to explain why the answer is 21. Okay, and that is as follows. We know that if you divide a polynomial expression by, for example, a bracket like, say, x minus a, so let's say x plus a. If you divide by x plus a, then the remainder, okay, of that division is found by substituting whatever makes this bracket 0 into the expression. So in this case, x plus a equals 0 when x equals negative a. So if I put x equals negative a inside the expression, what will come out is the remainder. Okay, what will come out is the remainder. Okay, let me just write that with me. So if x plus a is something that's dividing the expression, then the remainder of that division will be given by substituting whatever makes that x plus a equals 0, the value of x that makes that equal 0. In this case, is minus a. In this example that I'm giving is minus a. So this gives you the remainder. Okay, so in this case, we're dividing by x minus 2. Okay, so if you divide by x minus 2, what makes x minus 2 equals 0? What value of x makes it 0? Well, x equals 2. And if we take this and replace x with 2 inside here, of course, this is going to become 0. You'll have 2 minus 2, which is 0. Okay, that's going to become 0. And whatever this is going to be, of course, it's going to end up as, the whole thing is going to end up as 0. Because you're going to have 0 times whatever this comes out as. So you don't even need to know what this becomes. But you could say 2 times 2 times 2 squared plus 5 times 2 plus k plus 21. Well, this is 0 times something. And 0 times anything is 0 anyway. So we don't even have to calculate what this is. We know that the answer is going to be 0 when it's multiplied by this. Okay, so this is going to be 0 times whatever plus 21. So that's going to give you 21. So the answer is 21. As I said, you could just state it. The question says state, worth 1 mark. You can just see that when x equals 2, this becomes 0, and you'll be left with 21 as the remainder. Okay, so that's the remainder when f of x is divided by x minus 2. Right, now, for part B, it says, given that 2x minus 1 is a factor of f of x, show that k is equal to 11. Okay, so now here, what we're going to do is we're going to say, okay, in this case, we know that 2x minus 1 is a factor. Now, something is a factor of an expression when the remainder is equal to 0. Okay, so we can find the remainder as we learned earlier. We're going to find out what, if 2x minus 1 is a factor, then what makes this 0? 2x minus 1 equals 0, x equals 1 over 2. Then x equals a half, okay, or you can say f of a half. F half is going to equal 0, because when something is a factor, then the remainder is going to be equal to 0. Okay, f half is equal to 0. Why? Because if something's a factor, the remainder is 0. Okay, so when the remainder is 0, that means that thing is a factor. So they told us that this is a factor, so we know that therefore f half has to equal 0. And that gives us basically one unknown. So we can say that when we put half instead of x, we have a half, take away 2, times 2 times a half squared plus 5 times half plus k, and that's equal to, plus 21 is equal to 0. Okay, so that's like an equation we form now from this information. The only thing we don't know is this k. So half minus 2 is negative 3 over 2 times, this is 2 times a quarter, because a half squared is a quarter, that's a half, plus 5 over 2 plus k. What I'll do is I'll just say equals negative 21, just getting it ready to solve. Okay, so this is going to give you minus 3 over 2 times, that's half plus 1 over 2 plus 5, that's 6 over, that's 3 plus k equals negative 21. Let's get rid of this. Multiply both sides by 2 and divide by 3. The minuses cancel out because you're going to have divide, say, by minus 1 both sides. So you're going to have divide by 3, that's going to be 7. So you have 3 plus k equals, that's going to be 21 times 2 over 3. Just multiply both sides by 2/3 basically. So that will give you, that's going to be 3 goes to 21. 7 times 2 is 14. So 3 plus k equals 14. So k is equal to 14 minus 3, which is equal to 11, which is what we had to show, which is perfectly good. So it's good when they tell you to show something like this. The clearer that you lay out your steps, the better. The more steps you write, the better, just because they've already told you what the answer is. You don't want to just write something like this and then say, therefore, k equals 11. You have to show how you got there. So that's for part A, which is about the remainder theorem, and part B, which is about the factor theorem, which are basically related. When you divide anything, just like a normal number, if I say take the number 15 and I divide it by, say, 5, I get 3 remainder 0. That means 5 is a factor of 15. But if you do 15, for example, divided by 6, then I get 2 remainder 3. So when there's a remainder, it's not a factor. Okay, so that's basically the idea there. So when the remainder is 0, that means the thing you're dividing by is a factor. Now, for part C, it says hence. Hence means using what we just learned. So hence, it says fully factorize f of x. So first of all, it says fully factorize f of x. So I've got some of the things that we've learned already. One of them, that k is equal to 11. So let's first of all just rewrite this in a way that's a bit more friendly for us to end up factorizing it. So I'm going to write first the value of k inside the expression. So x minus 2 times 2x squared plus 5x plus 11 and then plus 21. So let me expand this and write that as one expanded expression. So x times 2x squared, 2x cubed. Then x times 5x, that's 10x. Then x times 11, that's 11x. Okay. Then minus 2 times 4x, negative 4x squared. Negative 2 times 10x, that's negative 10x. Sorry, that's plus 5x here. There's a mistake I made there, isn't it? Sorry about that. That's x times 2x squared and x times 5x. That should be a 5x here. Okay. And then x times 2x squared, then x times 5, that's 5x squared, sorry. Then x times 11, that's 11x, minus 4x squared, minus 10x, and minus 22, and then plus 21. Okay, that's better. Just make sure 2x cubed plus 5x squared plus 11x, minus 4x squared, minus 10x, minus 22, plus 21. So finally, we can just simplify this. You've got the only one. This is 2x cubed, only a cube term. X squared minus 4x squared is plus x squared. 5x squared minus 4x squared is plus x squared. 11x minus 10x is plus x. And minus 22 plus 21 is minus 1. So this is what the f of x actually simplifies to when we know that k is equal to 11. Now we know that 2x minus 1 is a factor of f of x. Okay, so if 2x minus 1 is a factor of f of x, then if we take 2x minus 1 and we divide f of x by 2x minus 1, the remainder will be 0. And when we divide them by using algebraic long division, then what will be left on top will be the quotient, which means these two are the two factors, or two factors of f of x. So we can factorize it that way. So what I'm going to do here, I mean, there's other ways of doing it. This is using algebraic long division, but this is probably the most common and the most popular way of students tackling this type of question. So I'm going to write these in order of size and be careful in case there's anything missing. We've got 2x cubed plus 1x squared plus 1x minus 1. There's nothing missing. All the orders are here. For example, if there was 2x cubed and then plus x squared would be missing. We'd have to write 0x squared in its place so that everything falls in the right value. But in this case, we don't have anything to worry about. Then we say, okay, 2x, we have to multiply it by what to give us 2x cubed? Well, just x squared, sorry. 2x times x squared gives us 2x cubed. Okay, so that's how you start. And then you say, okay, I need to multiply x squared with these two terms. So you're going to have 2x cubed minus x squared. And then these two lines we have to subtract. Of course, 2x cubed minus 2x cubed is 0. Be careful here because it's x squared minus, which is plus x squared, which gives us 2x squared. Bring down the next term and then repeat the same procedure. 2x times something gives us 2x squared. Well, that's plus x. Then we do the same thing. X times 2x is 2x squared. And x times minus 1 is minus x. So we have a very similar type of situation here as we just had. We subtract, we've got to be careful again. These two subtract to give us 0. X minus is x plus. X plus x is 2x. And 2x into 2x goes plus 1 times. 1 times 2x, and then you bring down the next term, which is minus 1. 1 times 2x is 2x. And 1 times minus 1 is minus 1. And if we did everything correctly, this remainder should be 0, which shows that this is a factor of that as we determined it. So this is a factor of this, and this is the quotient. So therefore, we can say therefore that f of x can be expressed as 2x minus 1 times the quotient x squared plus x plus 1. And this doesn't factorize any further. Okay, there's no numbers that you multiply to give you 1. And they also add to give you 1. There's no such two numbers that you multiply together to give you 1 and they add to give you 1. So there's no way to factorize this any further. Right? That's part 1. Okay, that's fully factorized. Okay, so now we have also an alternative way of basically factorizing this expression that we have. So I'm going to take it from the point where we had found that k is equal to 11. We'd already used that fact, and then we expanded this to give us this expression here, 2x cubed plus x squared plus x minus 1. And we have to factorize this given that 2x minus 1 is a factor of f of x. So what we can do here is we can do what's called factorizing by recognition. So what we can do is we can say, okay, I know that if I multiply 2x minus 1 with something, it's going to give me 2x cubed plus x squared plus x minus 1. And these two are identical to each other, right? So this multiplied by that should give us this, cubic expression. So of course, if you multiply a quadratic with a linear, so ax squared plus bx plus c, that's going to give us a cubic. So this bracket has to be of this form, such that when you multiply by 2x minus 1, you'll end up with a cubic. What we can do here is we can do something called comparing coefficients. So if I consider the coefficients of x cubed on both sides of this identity, I can try to find the value of some of these constants. So for example, ax squared times 2x, that's going to give us our cube term. So that's going to be 2ax cubed. And that's equal to the coefficient of x cubed on this side, which is 2. So we can say, therefore, a is equal to 2 over 2, which is 1. So I know it's going to be x squared. Okay. And we can do the same thing for the x squared term. We can do the same thing for the x term. We can do the same thing for the constant term. Now, normally the constant term is easy to deal with. The highest and the lowest are easiest because there's the least number of combinations that give us those. So for example, here, the only way to get x cubed would be x squared times 2x. The only way to get a constant term would be c times minus 1. So it would be negative c equals, and you've got a minus 1. So we can say c is also equal to 1. And to find the value of b, which is left, we can either choose x squared or x terms. Either of them is going to be fine. For example, if we choose x squared terms, let's look at the x squared term on this side. When you have ax squared times minus 1, that's going to be minus a. But then you got to be careful, because when you do bx times 2, you'll also have x squared term. So you have b times 2, which is 2b. This on this side of the identity, the x squared term is going to be given by minus a and plus 2b. Okay, nothing else will give us an x squared term, and that's equal to the coefficient of x squared on this side, which is 1. And we already know that a is 1, so you're going to have minus 1 plus 2b is equal to 1. So 2b is equal to 1 plus 1, which is 2. So therefore, we can say b is also equal to 1. So we found the values of a, b, and c. Alternatively, if you wanted to, we could have used the x coefficients to find the value of b, and it should give us the same value, just to show you that you do. So the ways to get the x terms when you expand this bracket is when you do b times minus 1, which is minus b, and also when you do c times 2x, which is plus 2c, and the x coefficient is 1, and we know already that c is 1, so you have minus b plus 2 times 1, which is 2, equals 1. So minus b is equal to minus 1. So as you can see, b is equal to 1. You get the same answer, whichever one you use, the x squared or the x. So now we know the values of a, b, and c. They're all 1, basically. A, b, and c are all 1. So we can say that f of x is factorized as 2x, as x minus, 2x minus 1 times, we're going to have ax squared plus bx plus c. So you're going to have 1x squared plus 1x plus 1. Okay, and that's exactly what we found when we did it by long division. 2x minus 1 times x squared plus x plus 1. 2x minus 1 times x squared plus x plus 1. So that's just an alternative way of factorizing this expression. Now that doesn't factorize any further, as we discussed earlier, and that is our final factorizing of this expression. Okay, so that completes this part of the question. Other questions. So this is just an alternative. This is like an alternative kind of method, you could say. This is by recognition. So it's the same question as we did part 1 before, but this is an alternative method. And now for part 2, it says find the number of real solutions of the equation f of x equals 0. So what we're going to do now is we've got this expression. So f of x equals 0. So 2x minus 1 times x plus x squared, plus x plus 1 is equal to 0. So this, when you try to solve this, you have a product of two factors equals 0. So either one of the factors is 0, so 2x minus 1 equals 0, in which case x equals a half. So that's one solution. And here, when you try to solve this, x squared plus x plus 1 equals 0, does it have real solutions? Let's have a look. We can determine whether something has real solutions by its discriminant. Okay, as we know, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. And if this has the number of real solutions it has is determined by what's called the discriminant, b squared minus 4ac. So the value of b squared minus 4ac, if b squared minus 4ac is greater than 0, there will be two real distinct solutions. If b squared minus 4ac is equal to 0, you'll have basically one real root, or you can say, repeated root. One repeated root. So it's one root that's repeated. Okay, and if b squared minus 4ac is less than 0, there are no real roots. Because if that's negative, you'll have the square root of a negative number. If that's 0, you'll have minus b plus or minus 0 over 2a, only one answer, minus b over 2a. And if it's greater than 0, you're going to have minus b plus something over 2a, that's one answer, and minus b minus something over 2a, which would be another answer. So that's what we have to do. We have to look at the discriminant, and the discriminant here, a, b, and c are the coefficients of x squared and x, and the constant, they're all 1 in this case. So b squared minus 4ac is going to be equal to 1 minus 4 times 1 times 1, which is going to give you a negative value, negative 3. So as b squared minus 4ac is less than 0. There are no real roots for this part. Roots. So we can say, therefore, only one real root. Okay, from this. Right, only one real root is found from this part of it. This part, produces no real root. So that's the answer to this question. And the reason is basically shown here. You don't need to write an essay or anything. That's fine. So that concludes this question. Question number 4 from the Pure Mathematics 2 paper from June 2024. Other questions from this paper can be found in the playlist that will appear in this region at the end of the video. Other questions from the topic of the factor theorem, remainder theorem, and algebraic long division, you'll find them in this playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video here which tells you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.